let us start solving exam 2 practice problems. So the very first question, it's saying that, let me find the question. Okay, question says, what are the extreme values? Exam 2. Practice problems. Well, question says, what are the extreme values of, what do we have? A function. This is the function. Function is given to us, x times y, subject to the constraint. So the constant function, the constraint function, g is x squared divided by 8 plus y squared divided by 2. Then minus 1. Okay. Well, one method is to going back to elementary calculus and saying that. So this is one method. If you're interested to doing that without using the Lagrange multiplier, one method is to write down x squared divided by 8 plus y squared divided by 2 minus 1 equal to 0, y squared divided by 2 equals to 1 minus x squared divided by 8, and y is plus minus square root of 2, 1 minus x squared over 8, and substitute this guy into the function. Substitute y into f of x and y equals to xy, and get function in terms of x and take the derivative, find critical values, and solve that. F of x is equal to x times square root of 2, 1 minus x squared divided by 8, and here we are putting this guy inside the square root. So get another square root. This is one method. And this goes inside the square root. And take the derivative, find the critical values. What you learned in elementary calculus. This is one method. Another method uses the Lagrange multipliers. Second method, since we are in multivariable calculus class, I expect you to know how to apply Lagrange multipliers. So we take the derivative of the first function, set it equals to the derivative of the second function. We are looking for the points where the gradient of these two functions are actually parallel in the same direction. We know that at those points, at those values, this function takes its optimal values, optimal z. Very well. So here, the gradient of f, taking the derivative with respect to x, you get y. Taking the derivative with respect to y, you get x equals to lambda. Then here you have 2x divided by 8, comma, 2y divided by 2. So we have y equals to lambda x over 4, and x equals to lambda y. Very well. What we can do? Well, we can just isolate lambda on one side and then substitute that into the second equation, or we can do the division, any method that works for you. Well, we can say that, hey, lambda is equal to x divided by y, and substitute lambda here, and we get y equals to lambda, which is x divided by y, times x divided by 4, and you find the relation between x and y as y squared equals to x squared divided by 4. So now you can use your g of x and y. You have a relation between x and y. Use g of x and y. It means that I know x squared divided by 8 plus y squared divided by 2 minus 1 is equal to 0. This is a constraint function. And y squared is x squared divided by 4. Let us use it. So here I get x squared divided by 8 plus y squared, x squared divided by 4 times 2, 8 is equal to 1. So what I have 2x squared divided by 8 equals to 1, or x squared equals to 8 divided by 2, 4. So my x is 2, my x is negative 2. So now x is 2, x is negative 2. What's the meaning of that? It means that I can plug those in here and find values for my y. So since y squared is equal to x squared divided by 4, well, y is plus minus x divided by 2. If x is 2, my y is plus minus 1. And if x is equal to negative 2, my y is minus plus 1. So I have actually 4 points. 2, 1, 2, negative 1, negative 2, 1, negative 2, negative. Now that I have all of those possible values that give me the optimal z value, I need to plug those in. So if I plug in 2 and 1 into the function, my f of 2 and 1 is just 2. If I plug in negative 2 and 1, I get negative 2. If I plug in 2 and negative 1, f of 2 and negative 1 is negative 2 again. If I plug in negative 2 and 1, I get 2. So the maximum values for the function 2 and 2, they happens as 2 and 1 and negative 2 and negative. There you go. Second question. Second question. Where are you? Second question. Second question says find the dimensions of the closed right circular cell. Perfect. Question 2. Find the dimensions of the closed right circular cylindrical with smallest surface area. Cylinder with smallest surface area whose volume is 16 pi cubic centimeter. So what are we trying to do? we're trying to maximize we're trying to find the dimension of the cylinder, circular cylinder, and I forgot the cylinder. Cylinder. With smaller surface area. So its surface area must be minimal. So this is our goal. The surface area must be minimal. So we're trying to minimize a function. There is a function that we try to minimize. That function is the surface area of the cylinder. What do we have? We have the volume. Must be minimal. Must be minimal. And we have the volume. The volume is going to be your g function. G of x and y is given to us. Is 16 pi. So let's see. So the volume is 16 pi. Let's just write these down here. Very good. So this is our right cylinder. Here you have your radius, which is r. Then you have the height and the volume, pi r squared h. This guy is given to us as 16 pi. We have our constraint or g function, if you want to think about this. The constraint is given. Now the surface area itself. Surface area, 2 pi rh plus, then, so here you are taking this cylinder and start opening this cylinder. Two pi rh. This is the surface area. 2 pi rh, and then you have the areas of these two disc as well as the area of the circles. So you can set it up this way: 2 pi rh plus 2 pi r squared. 2 pi r squared. This is the surface area of this cylinder. This is pi r squared, and this is pi r squared. Area of the surface is going to be like this. So our goal is to have this surface area to be in its minimum form. What are the dimensions? Well, what we can do here, you can just write r in terms of h, h in terms of r, and substitute that there and go back to elementary calculus. So one method is to write r in terms of h or h in terms of r and substitute that into the function f and take the derivative, find the critical values, and so on. Or you can use the Lagrange multiplier method. The gradient of s must be equal to lambda gradient of v. So gradient of s, taking the derivative with respect to r, then taking the derivative with respect to h. So here, if you take the derivative with respect to r, you get 2 pi h plus 4 pi r And then, so this is derivative with respect to r, and then the derivative with respect to h. This guy is going to be 0, so you get 2 pi r. S of h is equal to lambda. Now, we're doing the same thing here. The derivative with respect to r, 2 pi rh. The derivative with respect to h, pi r squared. Very well. Okay. So this is the derivative v of r, and this is v of h. Now we set these equal to each other and try to solve for lambda. So what we get 2 pi h plus 4 pi r equals to 2 times lambda pi rh. And on the other side, you have 2 pi r equals to lambda pi r squared. So from the second equation, you can cancel out pi and pi. Then you cancel out 1 of r, and lambda is equal to 2 divided by r. You can substitute that in the first equation, get rid of your lambda, and try to figure out what r is, what h is. So you can write this guy down as lambda equals to 2 pi divided by r. And then you can substitute that for your lambda here and start trying to solve for r and h. So by substitution, you can simplify that to 2 pi h plus 4 pi r equals to 2 pi divided by r, and you get 2 pi rh. So as you can see, you can get rid of r and r. No r is left here. So you can just cancel out all of the 2's here. You can cancel out pi here. You have pi. You have 2 pi, 2, and you get h plus 2r equals to 2 pi times h. Well, here you can write r in terms of h and use your relation that you have between r and h. Remember that after simplifying whatever it is, you have to use your constraint function. So here you can write down r equals to 2 pi h minus h divided by 2 and substitute that here. So you can cancel out pi and pi r squared h is equal to 16 pi and pi, they get canceled out. And here your r squared is equal to 16 divided by h. Or again, you could write h in terms of r if it's easier for you to solve. I'm going to write down both of these so you see you can use any of these methods. H is equal to 2r divided by 2 pi minus 1. So here you get r squared times 2r, 2 pi minus 1 equals to 16. Trying to solve for r.
Professor.
Yeah, I forgot to cancel this out. Here you only have 2 divided by r. Okay, so 2 divided by r, we don't have any pi left here. Okay, it makes it easier and simpler. So h is equal to, okay, we don't have any pi. Good, 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 much more easier to work with. Very well. So my h is equal to 2r. Just substitute that guy over there, and you get r squared h divided by equals to 16, and then r squared times 2r is 16, so r cubed is 8, and r is equal to 2, so h is 4. Very good. Now, these are the dimensions. If the question says, hey, find the surface area as well, we can plug those into the surface area and then calculate the surface area as well.